So, ByteDance just dropped Utar's 1.5, and the short version is this. It's a vision language agent that treats your screen like one big image. It can read, reason about, and then manipulate directly, instead of juggling DOM trees, calling external tools, or stuffing the prompt with handcrafted instructions. The model ingests a screenshot, figures out the layout and the task from plain language, and then acts natively as if a real user were at the controls. That shift, folding perception, planning, and low-level actions into one neural backbone, changes the game for GUI automation, game agents, and any workflow that lives inside a graphical interface. It's faster. It's more resilient when the UI changes, and in head-to-head benchmarks, it's already edging out GPT-4-based setups and Claude on everything from Windows desktops to Android apps to web navigation. So, they started with the original Utars a few months back, but version 1.5 is the beefed-up sequel. Under the hood, it's still Qwen 2VL at heart, but they scaled it three ways: a lightweight 2 billion parameter model, a mid-range 7 billion, and a chunky 72 billion variant that got an extra round of direct preference optimization across 50 billion tokens of training screenshots, element metadata, GUI tutorials, and bootstrapped action traces. The team taught the model to see, reason, and click in a single pass. The first big upgrade is how it looks at a screen. They scraped websites, Windows apps, Android UIs, even CAD and Office software, yanked the bounding boxes, the labels, the colors, the tiny 10 by 10 pixel icons, everything, and synthesized 5 flavors of perception data. Element descriptions tell the model, hey, that little blue square with the floppy disk icon is a save button. Dense captions stitch all the elements into a global paragraph so the model gets layout context. State transition captions teach it to notice subtle changes like the difference between a button-down frame and a hover frame. There's a giant heap of screenshot quanda so it can answer short questions such as, where's the new tab button? And they sprinkled in a set of mark prompting, basically drawing colored markers on elements so the agent can ground language tokens to specific pixels. Now, seeing is cute, but acting matters. ByteDance defined a unified action space shared primitives like click XY, drag, scroll, type, wait, plus desktop specials like hotkey or right-click. And mobile-only actions like press back or long press. On top of that, you get 2 meta actions, finished when the job's done, and call user when it's stuck behind a login wall. They collected millions of multi-step traces, open source stuff like Mind2Web, AITW, Android Control, plus their own hand-recorded sessions, and normalized every step into that action template. The average trace length is around 15 steps in their in-house set, so the model learns long horizon control, not just single taps. Reasoning is where version 1.5 really shines. The paper splits human-style thinking into System 1 and System 2. System 1 is the fast, intuitive, just-click-the-button vibe. System 2 is the deliberate, chain-of-thought, break-the-task-down vibe. Task decomposition, milestone recognition, trial and error loops, and reflection when things go sideways. They harvested 6 million GUI tutorials off the web, about 500 tokens each, 3 pictures on average, ran them through a fast text filter, a big LLM cleanup, and used that as a reasoning primer. Then, for every action trace they already had, they retrofitted a thought first with actory prompting, then with a clever bootstrapping trick where the model samples multiple thought action pairs and only keeps the pair that actually works. Those thoughts sit in context, so before every click, you literally get the model's inner monologue, like, okay, search field detected, type the username next. Because agents crash in real life, they taught the model to learn from mistakes. They spun up hundreds of virtual PCs, let an early checkpoint roam free, captured the messy traces, filtered the junk with rules and VLM scoring, and sent human annotators to label 2 critical steps, the wrong move and the correct fix. That gave them paired samples for direct preference optimization. DPO's job is simple. Reward the fix, penalize the blunder, keep the policy close to the stable SFT baseline. After a few bootstrapping rounds, they saw the 72 billion parameter model jump from 17-ish to over 24 points on OS World's 50-step budget. Alright folks, because everybody asks for the scoreboard in the synthetic desktop Sandbox OS World, Utar's 1.5 nails a 42.5% success rate with just 100 steps, beating OpenAI's operator at 36.4 and Claude 3.7 at 28. Windows Agent Arena, a tougher 50-step Windows challenge, shows 42.1% for TARS versus the old 29.8 baseline. On Android World, the 7B model pulls 64.2%, topping the previous 59.5. When it comes to naked grounding and pointing to a widget, ScreenSpot Vive 2 clocks UIR's 1.5 at 94.2% accuracy, Operator at 87.9, and Claude at 87.6. Next up, the new ScreenSpot Pro, which uses high-res professional apps, is where the gap gets crazy. 61.6% for TARS, only 23.4 for Operator and 27.7 for Claude. Moving on to gaming, they fed the model 14 pokey minigames, 2048 Infinity Loop Snake Solver, and so on. And the agent clears every single one, literally 100% across the board, while Operator and Claude flop on half the titles. Minecraft's Mineral L benchmark is more humbling, but still, with the Think Then Act mode turned on, TARS 1.5 gets a 42% average success on 200 mining tasks, and 31% on the 100 mob killing tasks. The older VPT or Dreamer 5, 3 agents barely cracked 1% on those same goals. To prove it's not just cherry-picked demos, they published the full benchmark table in the blog. For Web Voyager browsing tasks, it's 84.8% for TARS versus 87% for CUA, but for marginal mine-to-web online tasks, it's 75.8% against 71% for OpenAI's CUA. Notice the pattern on web browsing. Operator stays competitive, but once you leave HTML land, and especially once you hit desktop or mobile, UI pulls ahead. Scale tests are neat too. Take the original 72B DPO checkpoint on OS World 24, 6.6 points. The mid-size 7B version with the same training setup reaches 42.5 points because that one is optimized for desktop tasks instead of games. The tiny 7B Lite release clocks 27.5 on SpawnSpot Pro, 38.1% for the earlier 72B DPO, 49.6 for the new 7B, 61.6 for the full 1.5. So, bigger isn't always better. Targeted data and the thought engine matter more than raw parameters for grounding. Deployment is refreshingly open. They push the 7B checkpoint to Hugging Face under Apache 2.0 at ByteAnt's seed / Utar 1.57B. The full 72B weights are under early research access. You basically email Tarzabitants. From a research meta angle, the paper goes full history lesson. It tracks GE agents from old-school rule-based RPA to modular LLM frameworks like AutoGPT to these new end-to-end native models. Rule-based stuff is brittle. Frameworks are prompt engineering heavy and fall apart when a UI shifts. But native agents, being data-driven, retrain on fresh traces and just adapt. That's why ByteDance keeps banging on the 4 core capabilities: perception, know what's on the screen; action, hit the right coordinates; cross-de-reasoning, swap between System 1 and System 2 as needed; and memory. Store short-term context in the prompt, long-term lessons in the weights. Stick those in one model and you get something that can reboot itself when Windows throws a pop-up. Training followed 3 phases. Phase 1. Straight continual pre-training on everything. Around 50 billion tokens, flat learning rate. Phase 2. An annealing stage where they only keep high-quality perception, grounding, action and reflection pairs, so the loss focuses on difficult examples. They call that checkpoint Utar's SFT. Phase 3. DPO on the reflection pairs, which bakes in the preference for fixed actions. That's Utar's DPO, the model that hit 24.6 on Osworld on offline benchmarks. Things are already strong in multimodal Mine2Web. The 72B model posts 74.7% element accuracy and a 92.5 operation phone Android control. Low-level tasks, 89.9% grounding and a 91.3 success rate. Gay Odyssey's cross-app mobile navigation hits over 88% success, which beats OS Atlas 7B by about 26 points. Yet the more impressive bit is how System 2 reasoning starts to shine the moment you give the model more than one sample. In best of one sampling, the no-thought version sometimes edges ahead because the deliberate chain of thought can hallucinate. But at best of 16, the thought-based policy overtakes. And by best of 64, it's way better because the extra sampling lets the model explore multiple reasoning paths and keep the best one. Out of domain, deliberate reasoning wins straight away on Android World, which the model never saw during training. The thought-enabled 72B cleans up at 46.6%, while the reflex-only mode stalls at 34.5%. That generalization suggests the chain of thought is giving the agent a planning buffer, so it can handle surprises, kind of like how humans slow down when things get weird. For the broader community, the cool thing is that ByteDance didn't lock the data behind NDA. They dumped screenshots, annotation guidelines, and evaluation scripts. The license is Apache 2.0, which means you can throw it into a commercial product, tweak the code, sell the service, and nobody's coming for royalties. And because the action space is unified, click, type, drag, etc., people confuse their own data sources, say a specialized medical interface or an indie game UI, and keep the same fine-tuning recipe. And yeah, that's the drop. If you've been waiting for an open agent that actually moves a mouse instead of hallucinating JavaScript, this might be your playground. Smash like if you found this useful, sub for more deep dive AI stuff, and let me know in the comments what workflow you'd throw at Utar's first. Thanks for watching, and I'll catch you in the next one.